For those who may concern, this is a nifty constant current circuit that I built up at work for a project. Here it is in real life. The way this whole system works is no matter what kind of load you put out here on the output, it only ever delivers about half an amp. And the way it does that is with this in MOSFET and this transistor. So here we have the gate connected to the top of the transistor, so the gate's normally pulled high if nothing's going on, which makes this very conductive. Say you drop a short across here and short this out, the current will flow. It will flow through our shorted out MOSFET, and it will encounter this 2 ohm shunt, a large shunt, but not too much for half an amp. That makes a little voltage here, which then turns this guy on, which then makes this very conductive, which takes the gate and essentially connects it to ground. Once the gate is connected to ground, this is not conductive, so no more current really wants to flow through it. No more current, no more voltage over our shunt, which means this guy is now not conductive, so this floats back up. Anyways, you can see there's some sort of valley of stability we're descending into between this part and this part, and based on what you make this resistor, you can put a potentiometer here and tune it. It will decide the current that flows through the system. So that's pretty cool. Constant CCS, constant current control circuit. This is to control relays. The company I work for has 3 voltages of relay, and I've originally designed a system with 3 different voltage power supplies, but then realized all the relays have the same current that control them. So I said, instead of having a selector switch for what kind of relay is connected for the technician, you just use the constant current supply. You never have to select what kind of relay. This is to open or close the relay. The relay is controlled, whether it opens or closes depends on the polarity. So very simple, you just flip the leads around. So this is an H-bridge. This is an H-bridge with 2 relays. That's what it looks like, right? Very easy to make an H-bridge with 2 relays because you can never have shoot through with this kind of relay. So relay 1, relay 2, here's common, here we go. Middle, normally connected, normally not connected. Middle, normally connected, normally not connected. So that's the pinout for this. And what's really cool is I built this up, gave it to the CMs, and they liked it. But they said, hey, can you control all 3 relays at once? And I said, oh, I have to build 3 of these then. So now we have this guy, which is the same circuit, but now with 3 outputs. And here's the mono channel. Here's the tri-channel. I thought it was pretty cool. There you are. So you see, each one of these are the feedback systems that control the MOSFETs here with the BJTs, and these are 51K resistors that connect from above the shunt right here to the base of the transistor right here. So these capacitors are actually used to fire the relay, because it's kind of like a power pulse relay, so it takes a jolt from these capacitors, and upstream of that are these resistors. So you see the other one shows it better. So you see here, normally this capacitor is sitting at 24 volts, so it can deliver whatever current we need until it diminishes to this resistor, then limits the current. And this is so that you can't mash the button and basically destroy stuff like the power supply or anything else. If you take the load away and you mash the go button, you will reflect all of this power onto this guy if there's no resistor here. And I burned the crap out of my thumb doing this because I did that, cooked up a MOSFET. Those MOSFETs with 24 volts at like 1 amp, 24 watts a second, that's a lot of power, especially for these little tiny MOSFETs. So anyways, that is the circuit of the day, everyone. So I hope you enjoyed that. And I'll just walk you through this one. Here's the positive channel. Here's some fuses. I put them upstream. Right here we have our positive junction, so we have the 10K ohm resistors that power our gates and our BJTs, and then we have our capacitors after this resistor. I was going to use 2 resistors, and then I decided it was too much current, so I went to 1 resistor. It really is okay. They're 10 watt resistors. They're chunky boys. And then the output of the capacitor bank is here, and this is our go switch. So when these wires are shorted out, all 3 of these output wires here will see the 24 volts, and they'll supply 24 volts as long as the current doesn't go above about 500 milliamps. As soon as the current passes that 500 milliamp threshold, these MOSFETs will begin to shut down the individual channels. So here we have 3 channel output constant current source system. Very cool. So I tried to make that as concise as possible, but it's already been 6 minutes. Very good. All right, rock and roll. Bonus tip: if you remove this transistor with a op amp, which is the original version of this circuit, you can have a voltage controlled current source, which is pretty cool. Just keep in mind, this is inefficiently dumping a bunch of heat when you play with it. So, and then of course, this diode's really important for back EMF from the relays, because relays are super inductive. So they're not that inductive, but it's always good to put a diode on your output here. So, and then this changes the polarity by energizing these relays up or down. I already built one of these and sent them over, and apparently no one had done this before. So they wanted to use software, and I said no. I got an idea. All right, have a great weekend.